Okay, this is Chapter 11, Organic Reactions, Lesson 8, and this is the very last lesson in organic chemistry. In the last lesson, we talked about combustion reaction, addition, substitution, and esterification. In today's lesson, we'll finish up with a discussion on fermentation, saponification, and two different types of polymerization reactions. And then we'll get ready to do our last unit on nuclear, and we will do some review. There will be a review video posted this weekend that's review session 2, so be on the lookout for that. So the first thing that we're going to talk about is saponification, and honestly, the only way that I've ever seen them ask this on the Regents is in a multiple choice question. So if you can remember that SAP is only missing the O, and you will have soap, it might be a little bit easier. And this is the process of making soap. An ester is always on the left side, and an ester reacts with an inorganic base, meaning a base that doesn't contain carbon. In this case, it's usually sodium hydroxide. This is your base. And it produces glycerol, which is a byproduct, and soap. So we have an ester, basically, plus a base yields glycerol and soap. So what we have here is some type of animal fat that we're starting with. It reacts with the base. Glycerol is the byproduct, and here you see sodium palmitate, which is soap. Something very interesting about soap, whether it be dish soap or shampoo, soap has what's called a nonpolar end, which is this end right here, because it's a very long carbon chain, and it has a polar end on this side. So what happens is, if you remember, like dissolves like. So soap is interesting because it's called hydrophilic and hydrophobic. The hydrophilic end is the end that is a friend of water. The hydrophobic end, the nonpolar end, is the end that's afraid of water, because you know that polar will dissolve polar and ionic, and nonpolar only dissolves nonpolar. So the nonpolar end hooks up with fat and grease, and the polar end hooks up with water. So when you're cleaning your dishes and everything, the soap acts as a bridge between the water and the grease so that it can be broken down, and your body, your plates, your hair, everything gets clean. Now, I've never ever seen them put the reaction on the test, and if anything, you would have to just recognize it. So if you see some big complex molecule reacting with a base, chances are it's producing soap. More than likely, they just ask you, saponification is the type of reaction that does what, so you need to know that it makes soap. Fermentation, you need to highlight this one. This one's asked every single year. Fermentation is the production of alcohol and carbon dioxide from a sugar. And the sugar is acted on by yeast, which contains a specific enzyme that breaks down the glucose. So this is always going to be sugar, C6H12O6. This is going to be an enzyme, and that enzyme is called zymase. Z-Y-M-A-S-E. Remember from living environment days, anything that ends in ASE is an enzyme. And that's going to produce CO2 and ethanol, which is C2H5OH. We just did organic naming and writing compounds. You know that ethanol is 2 carbons, so if we were to draw this out, Here's our 5 H's, and then you have the OH ending. Again, this is glucose in the presence of zymase, which is an enzyme, is going to turn into carbon dioxide and ethanol. You have to know this reaction. I did not balance it. Let's see. We need 12 H's, so 5 and 1 is 6. So we need to put a 2 here. And now we have 4 C's. We need another 2 here. That'll make us 4 C's. And then we have 4, 5, 6 O's. So there's the balanced equation. Polymerization. Polymerization is the formation of large molecules called polymers. So remember the word poly, the prefix poly, means many. And they are made from smaller units called monomers. So a monomer is a small molecule and it's joined together to form a larger molecule, the polymer. And the easiest way for me to explain this is think of a paper clip, and you've used paper clips to make a paper clip chain. So the little individual paper clip is the monomer, and then when you link a whole bunch of paper clips together, you get a polymer, or your paper clip chain. Examples of natural polymers are starch, cellulose, and protein. And they used to ask these, I haven't seen it in a couple years, but at one time it was a multiple choice question. It would say, which of the following is a natural polymer? And, you know, only one of the starch, cellulose, or protein would be present. Protein's easy to remember because proteins are made up of amino acids, and you put many amino acids together and you get different proteins. Cellulose is found in a lot of things, but I believe it's also found in plants. And then starches are very complex. Some synthetic polymers are plastics, nylons, rayons, and polyesters. Now we're going to talk about two kinds very briefly. First of all, let me say with a polymer, they've never asked you ever to draw any of these reactions. You just have to know what polymerization is. You need to know the difference between addition polymerization and condensation polymerization, and you need to know how to recognize it. Well, when we talked about addition reactions, remember that we were starting with an unsaturated hydrocarbon, either a double or triple bond present. In additional polymerization, you're also going to start with an unsaturated hydrocarbon. And how we make the polymer is by taking a whole bunch of monomers and breaking that double bond. It's hard to see this, but this was a double bond here. It's very light. We take that double bond and we break it, and we then link them together. Because look what happens when I break this. If I do this, I now have two bond sites here and here. And if I take the second one, so what's going to happen is a bunch of these monomer chains will link together and get the polymer that you see on the bottom. In the case of vinyl plastics, ethene is used to make large polymer chains. Sometimes it's written like this. You'll just see one ethene molecule with an italicized N after it. And then you'll see the same molecule with the bond broken with an italicized N. And this N is equal to some very large number. And this isn't in your note packet, but it's worth writing down somewhere on the page. So I might have 250 of these ethene molecules, and when all the bonds are broken, they're linked together. It forms one big log chain. So if you happen to see anything with an italicized N in it, That's also addition polymerization because you're taking this double bond, breaking it into a single bond, and then linking them together. Again, you'll never have to write out those reactions. You need to know what they are and how to recognize them. The last one I want to talk about is condensation polymerization. Condensation should make you think of water, and what happens is water is formed as a product when making the polymer. So you form water and you have the polymer as well. In this case, they're showing you an example with an ether/ester linkage to join and create. So here you've got what's called a dihydroxy alcohol. And the reason why this is a dihydroxy alcohol is because it's got two OH groups, one here and one here. And here you have an acid. And when you take the acid and the dihydroxy alcohol, you're going to remove the OH and you're going to remove the H to form water. And when you do that, you get this ester combination. Now, this is not the usual one that I've seen. Again, you would never have to write this. So if you see some big funky diagram and you're removing water and you're making one big long chain, chances are it's condensation polymerization. More typically, I've just seen it with dihydroxy alcohols. So taking I'm just going to show you with two dihydroxy alcohols. Normally you would have a whole bunch of them, but the process is repetitive. So what's going to happen is I'm going to remove the H from here and the OH from here, and these guys are going to hook up and they're going to form water. And then what happens is what's left here simply hooks up with what's left here. And you get a whole bunch of these linked together. So that's basically it. So on the condensation and the addition polymerization, you just need to recognize it. You've got monomers linking up to form a huge polymer. In an addition polymerization, you're starting with an unsaturated molecule, so something with a double or triple bond. In condensation polymerization, typically you're starting with a dihydroxy alcohol and removing water. Fermentation is the production of alcohol and carbon dioxide through the fermenting of sugar by action of an enzyme called zymase. And then you have soap making. That's it. Have a great weekend.